name is Rita Sousa-Nunes and I'm originally from Portugal. I actually partly grew up in Coventry, in this country, from which I have very fond memories. For example, I remember being outside a lot, much more than in my home country, where Lisbon, the capital, is much more urban. And here, the access to gardens and parks was much more prevalent. So I remember being outdoors a lot and being fascinated by all the animals and plants that I could see. And then that was also fueled by all the David Attenborough programs and books. I was always fascinated by nature, in particular the living part of nature. And those days, my brother and a neighbour of ours were very keen chemists. They're a bit older, so they would buy not just these kind of kits you sell for children, but more sophisticated things, and they would build their own fireworks and then try and extract our pocket money by selling us these fireworks they made. And that was all interesting and fun, but for me it was really always the animals and plants that inspired me most. And so despite no one from older generations in my family being in science, it was quite natural for me to pick those subjects as I went along and had choices in school. And there was probably some influence from my older siblings that were also so inclined. And I think the scientific mind and developing of a scientific mind is a way to approach the world much more than any one subject. It is valuable for any chosen career, really, and exposure to science develops your questioning, our reasoning, critical thought, humility, because we're often wrong, and we learn how much we don't know, comfort with dissent and argumentation, which can be done cordially and doesn't have to be aggressive. And these are many attributes that you can apply to anything, from politics to, more obviously, medicine, through everything in your day-to-day life. And you're probably aware now, more than ever, of the importance of scientific literacy in all sorts of decisions that are crucial to our life and our world. So you're very aware of all the debates around vaccination, probably, and around climate change. Is it true? Is it not true that it is man-made? What can we do to avert it? Nutrition, what we ingest, what we drink, what we smoke or don't. The importance of making these decisions, they are all based on scientific arguments. Going maybe a bit further from what you're immediately aware, but some of you may realize that there's a lot of discussion about research or not on human embryos and with what limits. Questions around fertility and fertility treatments. Questions around psychology and the importance of early years on later mental health. So whether or not you consider a career in science, I'd encourage you all to explore, as far as your interests go, all these STEM subjects. It will benefit you immensely, whatever you choose to go on to do. And I think it will benefit society that more of us are ever more scientifically literate and empowered to make the best decisions we can make. Myself, I did the equivalent of what are A-levels in my hometown of Lisbon, and those were on maths, chemistry and biology. And then I chose a degree in biochemistry, also in Lisbon, because I wanted to delve deep into the molecular underpinnings of life and what was life and how life worked, which was what most fascinated me. Our final year of this degree was full-time research for a whole year, and I worked on metabolism of astrocytes, which are a subtype of what we call glial cells, which are or have often been referred to as a support cell type for neurons that everyone cares about. But the more we know and understand about glial cells and astrocytes in particular, the more interesting they appear and the more important. They're involved in anything really that neurons do, and so they should not be neglected. Then I moved back to the UK, but this time chose London and pursued a PhD in developmental biology. I actually worked on how how very early decisions are made within the cells of an embryo. And when I say early decisions, I mean axis formation, how the embryo cells decide where will be the head of the embryo and where will be the tail. And of course, where the head will be is where the brain will develop. So I was always explicitly and implicitly always very interested in the brain, and that is probably because of a very strong interest in psychology as well. And psychology and brain structure and function are very related, of course. So after my PhD, I then turned into neural and neuroscience a bit more explicitly by focusing on neural stem cells. And that's what I've worked on ever since, and neural stem cell behaviours. And when I say behaviours, I mean things like when these cells decide to divide or not, when they decide to divide, what kind of daughter cells do they generate, neurons, how many, what types, or also these glial or support cells, how many and what types, whether they decide to whether they're able to do this in a safe way, or whether they can become go awry and become dangerous, like generating cancer. So we know that all cancers, and brain cancers in particular, also have stem cells, and these are the cells that largely drive the cancer and make it dangerous. So if we want to cure cancer, we also want to eliminate these stem cells. So I'm interested in both the normal neural stem cells and the brain cancer stem cells, and that's why I have been funded by Cancer Research UK, which is how I started my own lab with a fellowship of theirs here at King's College London in 2012. So we've been working on these sorts of behaviours by both normal neural stem cells and cancer stem cells, and we kind of poke these cells metaphorically with all sorts of genetics and chemicals and even physical methods to see if we can perturb them and to see how they react, what that teaches us about how they function. So it's fun. We have to devise interesting ways to poke them or question them, perturb them, we often say. And science and research is beautiful, and it is also adventurous. So it is intellectually adventurous, as you may gather, and as I've been saying, that we try to devise interesting ways and informative ways to poke them. But it's also adventurous in other ways. It provides opportunities to go abroad. Moving and mobility is encouraged in science. So I've experienced scientific research in my home country of Portugal, in the UK, and also in a third country, which was Singapore, during my postdoc years. It also really enables you to meet people from all sorts of countries and cultures. And even in my reasonably young lab here at King's, I've counted, and we've had students and postdocs and any lab members coming through from 20 countries now. And that's really interesting in itself. So I hope you can experience the beauty of STEM subjects and all they have to offer in terms of exploring your curiosity and your adventurous streak, both in the intellectual aspect, but in many other ways. So I hope you find the value and the benefit and the enjoyment of exploring these subjects, whatever you choose to do.